Student, in this video I am going to discuss about relationships among numerical variables. In the previous video I have discussed the relationships among categorical variable and also categorical and between numerical variables. So to understand the relationship among numerical variables, we need to understand three basic things like what is correlation, what is covariance, and a different type of plotting technique, that is scatter plot. It is not mandatory that you need to use correlation or covariance. Only need to apply on numerical variables. You can apply it on categorical variables also, because people use numerical data in case of categorical variables also. So point is that you can also use that type of measurements to find the relationship among categorical variables. But if you investigate that, if you want to investigate relationships involving categorical variables, it is better to employ the tools in the previous two sections. Is the relationship among categorical variables or relationships among categorical and numerical variables. Try to go through the previous sections and the tools that used to find the relationships. But it is advised, or it is very much useful to think about correlation and covariance in case of to find relationships among numerical variables. So first we'll try to go through scatter plots. Scatter plot basically it plots points in a Cartesian geometry in xy direction, having the variable x and y. Okay, you can see in this this is chart of data. Here different type of numerical variable exists. You can plot the scatter plot using different type of variables from this data. So you can see the example of the graph here. So this one scatter plots of age versus events and earnings, or it might be age versus earnings of 11, or earning versus events. In this way you can plot the data in scatters of points. This x direction, this y direction, this x variable, this y variable, and in that way you put the points of this data, okay, according to data you have in the graph, and it is scattered. So now in the scatter plot you can put a trend line, or you can say fitting line. Okay, so we can use a trend line concept in scatter plot. You might find that same thing in Excel also. So suppose this is the data, you have to fit a line with this data, a straight line. You can choose curved lines also. Here you can see it might be exponential line, it might be linear line, okay, it might be logarithmic. So the trend line is up to your choice, but we can, for this understanding of correlation and covariance, we are going through this linear line. Okay, so we can plot this trend line which shows the trend of the data, trend of the xy variable data, and this trend line has a equation. So here you can see equation of that line is y equal to minus 1.0623x plus 356.81. so this is the equation of this trend line. So next, depending upon this data, depending upon this scatter plot, we will try to find out the correlation and covariance. You can find the equation of this covariance. How to find covariance here? Here you can see covariance of xy equal to basically the summation of these terms. This is the any sample minus mean of that sample and the y value of that sample. This is x value, y value, yi minus y mean divided by n minus 1, or you can say the sample number. Okay, that is actually the average of this thing. So what it does, how it does, uh, you can see it is essentially an average. It is essentially an average of products of deviation from means, means how the values are deviated from the mean, and that are product if x and y vary in same direction. So try to put some focus on this. If x and y vary in same direction, then when x is above its mean, y will tend to above its mean. Okay, and if when x is below its mean, then what will happen? Then y will also tend to below its mean. In either case, the product of the deviations will be positive, because a positive times a positive or a negative times a negative is positive. So the covariance will be positive. The opposite is true, means that there will be negative value when x and y are opposite direction. In that case, the value of that covariance will be negative. So what we can study from this covariance is that how the data will be there along with the trend line. Trend line is basically, we can say, the mean, but not exactly the mean, but it follows as much as possible with the mean of the data. Okay, so that is what it's saying, that the value of the covariance will give you the direction of the x and y, or it will give the idea about x and y value with the trend line. But it has some drawback. Covariance has a serious limitation as a descriptive measure, because it is very sensitive to the units in which x and y are measured. And if x and y value are very much different, for example, a covariance can be inflated by a factor of 1000 simply by measuring x in dollars rather than thousands of dollars. These limits of usefulness of covariance as a descriptive measure, we can go for another technique, that is correlation. You can find the equation of correlation here. Correlation of xy is actually covariance of xy divided by standard deviation of x into standard deviation of y. And one unique point of this thing is that the value of the correlation is unitless. Okay, because the value of the covariance will be divided by value of the standard deviation x multiplied with standard deviation y. And here you can see the correlation is not only unaffected by the units of measurement of the two variable, but it always between +1 and -1. The value will be always between +1 and -1. The closer it is to the either these two extremes, then the points in the scatter plot will be in a scatter way from the straight line, but either in negative or positive direction. On the other hand, if the correlation is close to 0, the scatter plot is typically a cloud of points with no apparent relationship. So here you can see there will be no relation. It means, on the other hand, if the correlation is close to 0, scatter plot is typically a cloud of points with no apparent relationship. It means that there will be no relationship among the points if the correlation value is 0. But if the correlation value is -1 or +1, we can say that those are following the trend line. Okay, it means the closer it is to the either of these two extremes, okay, to extremes, the closer the points in a scatter plot are to a straight line. Okay, try to remember that. However, although it is not common, it is also possible that points are also close to a curve and have a correlation close to 0. This is because correlation is relevant only for measuring linear relationship. This is very important part. Correlation is relevant only for measuring linear relationship among the variable. Okay, so that is about correlation. So correlation, there is a difference between correlation and covariance, and the use also difference. We can use it in the various scenario, and most of the time correlation is used, but you can also use covariance to find the relationship among the variables. But correlation gives a more unitless and very that variable the measurement remains in this bracket, that is -1 to +1. So here you can see we first make three important points about the roles of scatter plot, correlation and covariance. A correlation is a single number summary of a plot, and you are usually on the lookout for large correlation, those near to -1 or +1. But how large is large? That is a very good question. And third is, do not even try to interpret covariances numerically, except possible to check whether they are positive or negative. So that is one suggestion. That point is that do not even try to interpret covariances to find the relationship among the variables, among the numerical variables, unless you want to find that the covariance is positive or negative. It means their direction of those variable might be opposite. To find that thing, only you can try for covariance, but not for all. So that is all about. So here you can see one question, objective actually, basically to use correlation to understand relationship in the golf data. So this is your homework. Try to go through this. The data of the golf data is available in this book or in this context, in this chapter. How we can find a correlation and how we can understand the relationship among the numerical variables. Try to go through this. Okay, if you find any difficulty to understand, please let me know. We'll try to have a meet over Google Meet. Here you can see some views of that problem. It's showing there's a correlation measurement 0.884, which is closer to +1. And now how that they are related to this trend line. Please try to go through it. Okay, and that is all about in this video. If you have any doubt, please mention. Thank you.